Here is a schematic drawing of a diaphragm pump which is pneumatically operated. You can call it as a Welden pump, as Welden is the prime manufacturer of such diaphragm pumps. On board ships, the typical use of such pumps are mainly for emergency purpose. Like you can find one such pump in the soap-up locker, where you can easily transfer it and use it anywhere you want to pump in emergency. Some ships have such pumps fixed in the engine room, approved by the class for sludge and bilge pumping, etc. However, majority of the ships use it for the portable pumping means. Now the idea of this video is not just to explain the operation of Welden pump, which everybody know, but the main purpose is to concentrate on this unit, that's the air distribution unit, and understand the complete working of the Welden pump. We all know air is being delivered on either side of the diaphragm so that the pumping action happens. But do we really understand the air distribution unit? In this video, we will address that and completely understand, so that when there is a trouble in it, we need not call our senior engineers. We can solve it ourselves. Alright, so to proceed further, we have to understand the basic components and parts. Here is the central rod, which houses a plate on either side. In between there is the rubber diaphragm, which is the main component for the pumping action. And here is the suction line, within which the oil or any liquid is being sucked on the suction manifold, and then the pumping action happens at these chambers, and then here are the discharge valves. It goes to the discharge line. So that's the simple arrangement. Now going little bit further, through the air distribution unit, air is distributed to the back side of the diaphragm, alternatively on either side of the diaphragms. So let's assume that the air is being pushed into this unit. The diaphragm moves out so that the other side of the diaphragm moves in, creating suction, and here the discharge happens as the diaphragm pushes the fluid out. Here you can note the balls, 4 in number, which act as valves, and here are the valve stoppers. Here is the valve seat. So when the air stops going behind this diaphragm, now the air is alternatively diverted behind this diaphragm. So this diaphragm moves out, pushing the liquid out to the discharge manifold, and this diaphragm moves in so that it creates suction, pulling in or sucking the fluid from the tank, or let's say some through the pipeline. Now the main point over here is how does the air gets diverted to either side of the diaphragm alternatively. That's the main area we have to understand. It's been a gray area, and I have learned a hard lesson understanding this stuff. So let's concentrate on this. So we have the engine room control air supply, which is usually 7 bar, coming to the air supply manifold or air distribution valve unit, which is indicated orange in color. And after that, you got to notice whenever you go on board, there are 2 lines. One is the main air, which operates the diaphragm, and other is the pilot air. Both are 7 bar, but that's called as pilot air. I call it as pilot air just for easy understanding. Since we know the air starting of the main engine or generator as main air and pilot air, similarly the main air is one which operates the diaphragm, and the pilot air is one which operates this spool valve, or even you can call it as pilot valve. Now the main air inlet is this, and here is the main air outlet or drain. This is pilot air inlet and the pilot air drain. The main air to the diaphragms is controlled by this spool valve, shuttling between the left and right. And the pilot air supply to this spool valve or the main valve is controlled by this long rod. We will go step by step and understand its function. Now at this position, the left side of this diaphragm, as I'm indicating here, has completed its stroke or completed the discharge action, and the right side diaphragm has completed the suction action. So the shuttle valve or the main valve opens up, the main air inlet comes through this, and this port is connected, and this goes behind this diaphragm. It's going to push it now. Let's watch it. So air comes and then it's going to push now. Alright, so now the air pushes it, so the diaphragm moves and then this starts to discharge. Now let's concentrate on the air distribution unit. Here is the main air. This main valve has created a passage, or both the ports are connected so that it comes over here. When you look at the other side, this is being blocked. The main air cannot pass through this main chamber to the other side of the diaphragm, as the main valve is blocking it here. Let's watch it once again. Discharge, and then this is sucking in. You can see that the main valve shuffles between left side and right side again and again, just diverting the air alternatively to either side of the diaphragm. Now the question is, how does the shuffling happens, or how does the main valve shifts from left to right and back again? For that, we got to understand the pilot valve over here. The diaphragm is circulated or encapsulated between two plates. So this plate is provided for a specific purpose. The plate, as it comes towards the inner end of the stroke, pushes this pilot valve. Same happens on the other side. As this pilot valve moves, it covers and uncovers the pilot line alternatively. Let's now see it. You can see the pilot thing is moving. So this is how the air is alternatively supplied behind the main valve, so that the air is diverted alternatively to the diaphragms on either side. I will explain this concept once again so that we get it clear. This is the main air inlet, main air drain, the pilot air inlet and the pilot air drain. Now the main air comes through this. As this port is opened up, this goes to the back side of this diaphragm and then tries to push it out. The main air does not go to the other side because this is being blocked by this main valve over here. Now let's concentrate on the pilot side. Before going to that, as this is being pushed, the air is getting trapped. It has to be drained. So the same passage is used for draining. Now we can trace this passage and you can see that this is connected to the drain of the main air. So this is the main air inlet and this is main air drain. So the air over here drains out. That's why you get a sound when the pump is operating. Shuck, shuck, shuck. That's the reason. Now let's go to the pilot side. So this is the pilot inlet and the pilot drain. Now the pilot valve is at central position over here now. So the air goes here and then it's getting blocked. It cannot go behind this main valve and operate. But on the other side, you can see the pilot air can go through this, and then it has pushed the main valve, and then it also gets filled up in the drain chamber, but it cannot drain because the drain is being blocked. Now let's see the pilot operation. Let's concentrate only on the pilot. As the pilot is moved by this, now this has moved, so there is no point that the pilot air should go and operate this piston. So on the other side, the pilot air goes here and then pushes this piston so that the air gets connected, the main air gets connected and pushes this diaphragm out. That's how it works. Let's see this animation. So for every air inlet and outlet, we can hear two sounds: chuck, 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 chuck. So both these sounds are draining sound, one from the main air and other from the pilot air. So now once you understand this thing, you can very confidently troubleshoot if the pump is not pumping. The major critical areas are: number one, the valve remaining open, as some sludge accumulation can happen at the valve seats. It may, or maybe on the discharge side or the suction side, so anything may happen. So usually this is the one where the ball gets clogged and then suction or discharge doesn't happen properly. So we can remove this off and then clear off the dirt and then put it back. And one other thing is the diaphragm itself getting cracked or spoiled. Let's say the sludge temperature is as high as sometimes 100 degrees. If we didn't keep it at the optimum temperature for sludge transfer is around 40 to 50. 70 is acceptable, but there might be a problem with this kind of pump, as some water in the sludge might evaporate and create a vapor lock. So for that reason, we maintain 50 to 60 as an optimum temperature. And other critical area where the problem might occur is these valves, either the main valve or the pilot valve getting stuck. Usually if the pilot valve gets stuck, you just have to tap it. You just have to remove this casing and then tap it, and then so that the pilot valve starts to shift. But this is very, very rare to happen. And there are chances if the air, that's the control air, having some moisture in it, the main valve getting rusted or something, but usually this doesn't happen. This is also a rare phenomenon. On board ship, we never touch this air distribution unit until and unless we suspect that this is the only problem which is happening. So that's it about the Welden pump working mechanism. And there are lots of pictures which is being displayed along with this article. You can see that, and the credit goes to Welden pump manufacturers for creating such a beautiful simple pump. And this animation has been used just for education purpose. I have not created this animation. And a small request from you all: if you like this video, there is a small thumbs up button there. Just click a like so that it gives me a feedback on how well I have explained this video. If you don't like, just post a comment so that I can improve upon my presentation.